So let's begin while waiting for Nishan. So hope.
Hi
Uh,
everyone. Sorry about that.
yeah, you're here. You're here. Okay, good, good. Hi, Nishan. Good evening, or good evening to you. Uh, but just, I mean, since I started to share the screen, so I will very briefly go through the assignments, home assignment that we worked together on with your team in La Trobe. So basically, connecting to yesterday's class by Nishan. So for the home assignment, you're proposed to explore the interaction between uh, uh, foundational models or large language slash large reasoning models and formally represented knowledge, so knowledge graphs. And for this purpose, we selected two data sets for use. I mean, those are benchmark data sets in the area of AI and reasoning. So these are Hotpot Q&A and Clutter from Facebook. Um, so all in all, so in both data sets, the task is given some textual description, answer questions which require logical inference, and passing these data sets through LLMs manifest in many cases in what we call hallucinations. So what you propose to do is to explore how formally represented knowledge in form of RDF knowledge graphs can assist in reasoning, and you will be working in um, together with LLM. So basically, your reasoner will assist LLM in taking decisions. And we formed the assignment such that you don't need to have a paid account for LLMs. So we packaged access to LLMs in a Docker image, so you need to install it. And we defined certain tasks. So we developed a skeleton on how to interact with LLMs, but you need to write some wrappers like Python code for starters to actually reason on the graphs. And also, so you will interact via Docker image with LLMs by engineering prompts, which would assist extracting better quality knowledge. So that's a very, very high level um, instruction. So you follow the instructions here. So this document PDF contains the description on how we will grade the assignment, but practical details you find in a student resources zip. So there is a student guide txt file which explain you in step-by-step manner what you have to do. So if you have concrete questions, so let's move it to the end, towards the end of the class. So now I give the floor to Nishan, back to Nishan.
Thanks, Evgeny. And thanks everyone for joining back in. So what I thought we can do today is we'll just take some of the concepts that we looked at yesterday. So we did a kind of bit of an overview of everything starting from, kind of the origins of natural language processing. We went into kind of what are the earlier predecessors for large language models, everything from your RNNs to your LSTM, GRA, to transformers, BERT, and then we kind of walk through things like RAG. We looked at semantic similarity, vector search, embeddings, and then we ended up with agents, right? And so I thought we can just look at a couple of these different concepts and ideas um, in terms of things like in terms of some practical code that's running. And then you can, I'll just expose them to you in terms of work or notebooks, which you can then go in and try them out. Right. So I think what we'll do first is, um, if you have not, or everyone have a chance to set up Neo4j?
Yeah, I did it
Oh,
yesterday.
great. Thanks, Walter. That's great. What about everyone else?
Can you probably write in the chat? So everybody, so come on, it's early, but wake up. It's
Yeah.
also dark. It's also super dark here, Nishan, so you need to give a discount.
Oh, I see. Oh, okay. It's quite bright here. So it's,
At
yeah,
least
I'm
discount
thinking.
on seeing the replies, responses. Okay, so another one sign up.
Okay, great. So I'll just give you 5 minutes. Just sign up, and you can even try out the first few kind of URLs that they have. They have kind of some notebooks there. Just run it and then you can start it up. The reason I wanted you to try it out is it's like your own personal little knowledge graph in the cloud, right? So you don't have to set up anything on your own machine. Um, and they have some nice little data sets that you can run it. So I'll just give you 5 minutes, and then basically we can come back and we'll start up. All right. Is everyone doing okay?
So let's see. So I posted the
Yeah.
link. Okay, so done.
Okay, great.
Th- yeah, put a thumbs up when ready. I mean, maybe 30 seconds more, and then we continue. So
Yep.
you can. Okay, so we start to get a critical mass here.
Okay, great. Sounds good. Um, so once you're in, what you would see is you would see an interface like this. So initially, of course, what you will see is you will see something like this, right? You would see instances, and then you would have one free instance running. So generally, the way that this works is Neo4j is an open source tool. You can actually host it yourself, or you can host it on a cloud platform. So when you were setting up, it would have asked you, okay, shall we set it up on a Azure cloud? Um, so essentially, once you set it up, it'll kind of spin up an Azure instance for you, or AWS or Google Cloud, or whichever you might have wanted. And then it sets this knowledge graph or graph database up for you on the cloud, right? And so once that is up, it kind of runs it's a very small instance here. I mean, generally when you have these graph databases, they can get quite large, but this is enough for our purposes, right? And so the reason I asked you to kind of set it up for yourself is you can experiment a little with this, right? These are all production grade graph databases. And generally, they are used quite often within organizations and also as hobbies projects or within personal projects. And can be quite interesting to work with, right? And especially in terms of all of the work that you're doing now. I believe you've been working with Protege so far. So this just gives you a little bit more of a graph database based
Mm.
implementation. Evgeny, was that right?
Yeah,
You've
yeah,
been working with Protege.
that's right. Yes.
Okay. So this just gives you an alternative, right? And allows you to kind of build up some
And
production
I would say
workloads.
more kind of more useful alternative because Protege was kind of chosen as a a logical continuation of the RDF story and the transition to OL. So, but graph
Oh, I see. I
databases.
see.
So that's practically used as you say.
Yeah. So now you have both sides of the coin as well. So interestingly, you can't actually run Sparkle here. You won't be able to run Sparkle here because these databases don't have an interface for owl-based representations. Uh, if you want to do that, there's another database which is called GraphDB, which is also open source. You can actually run that, and that has a Sparkle interface that you can actually go into. What I'll do is I'll just put some notes in place and I'll send them across. So if you want to try out GraphDB, you can. But for our purposes, I think Neo4j really kind of ticks all the boxes. And the good thing about Neo4j is there's enough material out there for you to kind of even do additional explorations if you are interested. Right. So this basically just shows you. And so if you can see, these are generally, this like a very typical implementation in terms of how cloud platforms are set up. So you would have some sort of console, and then inside that you might have different items that you can actually click into. So they have a lot of help resources. So let's say even if you were to approach this as a total newbie, you don't know anything about graph databases, this is a good place to kind of go and just try out things as well. Right. So here there are some interesting implementations. So if you want to, so currently what we'll do is we'll actually work with our own kind of data set. But if you had wanted to, you can actually go in and you could import your own database or your own data. So there's a data samples that you can try to import in. Also, if you are going to work with graph databases, generally use this query language called Cypher. Evgeny, was there something that we were focusing on in the course as well? Cypher, was that
No,
something that you...
no,
Okay.
no.
Okay, Cypher is just a language in terms of being able to query graph databases, right? So interesting, this interesting part of things. Normally, I would actually take a whole session just to explain what Cypher is and how it works. But we do live in the world of large language models, so these are very trivial now. You can just give a natural language question, and it'll be able to provide you what the cipher for that question would be, right? So I will leave it to you for your own exploration. But if you want to actually go in and kind of see how Cipher actually works, this is a good manual. You can see, as we were talking about last time, everything is represented in triples. And then you have different queries that you can use to be able to engage with these triples, right? So this is how you would actually engage in terms of inputting that information into the database. And if you were to query it, you would run something like this. So as you can see, it's very similar to what a structured query language or SQL would be. You have these keywords called match. Then it talks about the class of person that you're trying to pull up. And then it returns that as a language. And then we'll just try that out here as well. Right. So that is querying your data. So first thing is actually being able to import your data, then querying your data. And then, of course, you can actually build out applications based on this, right? So, I mean, again, they have quite a few in the developer hub as well. They have example GitHub repositories. That's the good thing about most of these technologies, right? You have enough and more information, then you can actually go in and see. So, for instance, this one is around Twitch, and they actually take a whole um, database from Twitch and they kind of represent it uh, within the graph database, and then they kind of do like the traditional implementations around it, right? So as you can see, these can get a little bit complex in the way they're run. So what I would say is like just start your way up to it towards what you're doing with this, right? Great. So that's your getting started points. And then for also you have these things, basically you can monitor your instance in terms of metrics and the like. So, obviously when you're actually hosting this in the cloud, there is a machine of sorts that's running in the background. So this actually shows you your CPU usage, your storage, whether there have been any out of memory errors. Generally, when you have large graph databases or any sort of databases, this is a very common thing that you probably might see. Then, of course, it shows you all the instances that you're running, and then it shows you, CPU statistics around these. And then finally, it shows you how much you're actually, in terms of the actual database itself, what the statistics are like. So, how big the size is. Here we're barely using anything at the moment. What the querying rate is, latencies, transactions, what are active transactions at the moment, or entities. So all of this kind of, you can just look at some meta information regarding your graph databases, right? Great. So then the next thing we'll do is we'll come in here and we'll have a look at the instance itself. So it's running a single instance here. And what I want to do is, so again, the metrics for all those instances, what I would want to do is I would want to go in and explore or query this instance, right? So for in this particular instance, I have just created a couple of different entities here and connected them up. And so if I inspect each of these elements, you can see this is of a class person. So you have class, a group, and a person class. And so inside that, you have different attributes. So the first one is what we call embedding. We have an ID, we have a name, we have some a profile and a title. And then you have a relationship, which is actually representing two nodes there, right? And then you have different, and you can actually go in and see what these different types of relationships are as well, right? And then, of course, you can actually query this information as well. So remember, we talked about how we wanted to query something. So let's say if I want to retrieve some of the information that I have, I can just say person, and I can say return P. You remember the syntax that was there. And if I run this, it'll just return all the different people that are available. So it shows me Bob and Alice. These are two people that are actually based on the database, right? And so you can write increasingly more and more complex queries here. And so essentially, if you look at things like, can you give me an example of where a graph database will be very, very useful? Something that you might actually be very familiar with.
Can you repeat the question, please?
So can you give me an example of where or a use case, something that you interact with on a daily basis that would benefit from having a graph database behind it? So if you think about graphs, it connects, essentially it's a connections, right? It's looking at links, entities, and then relationships between those entities. Is there anything that you can think of that has similar?
Yeah, if you develop like large software, like using object-oriented, like which relationships the classes have with each other.
Yeah, that's it. That's interesting. So, Walter, like, can you think of any particular software applications that we use that has this kind of characteristic?
say most graphical user interfaces because you have a program in the background and you usually have something to draw the foreground or to manipulate
Okay.
the window. So then you have one. Let's say if take we have the if we look at it like a back end forend kind of thing that you use the forend to
Okay.
draw out the things you want on screen.
Right. That's interesting. And that's one way of looking at it as well. So if you look at some of these applications, right, like you said, like some of these applications can actually make use of, um, that's right. Applications actually make use of some of these databases, right? So normally you would have some sort of SQL database that you use. Now, graph databases are really effective with modeling relationships, right? So I think Binay had actually mentioned it. Social media based implementations generally always have a graph database behind them. So your LinkedIn, your Facebook, your Instagram, it's all based on this thing of entities and neighborhoods, right? So you're looking at yourself, your friends of your friends. And so being able to query those kind of relationships are very, the graph databases become very easy to kind of manage relationships. So you can actually look at, who are your first level friendships, who are your second level friendships, who are your third level. And so those queries become very easy when you use graph databases. Whereas if you use things like traditional SQL databases, those it's not that it's not possible, it becomes increasingly difficult, right? And like you were mentioning as well, Walter, if you take organizational data information that you have, let's say like your knowledge graphs or your knowledge repositories, graph database again become quite powerful because now you can look at all the different types of information on that in that knowledge sphere and connect them up, right? So those are two kind of places where graph databases really excel. Another place that people actually use graph databases would be where they do things around fraud detection. Again, it's be able to kind of analyze patterns in terms of how transactions kind of evolve, right? And being able to actually transverse these different relationships make it very easy to work with, right? So thanks for that contribution. I mean, that's good that you have been thinking through these as well. So one way you can actually try this out outside of this is you can actually look at, let me see if I can find. So here there are some sample data sets that you can try out this implementation with. So here's the first one is a social network analysis, right? So that means essentially, you can, if you go in here, I'm just going to continue and use the guide data. So essentially here, what can happen is you can actually use, where is that? You can actually go in here. I'm not going to do this now, otherwise it'll actually go in and overwrite my information. But what you can do is you can create a new instance of this database that is giving you. It'll populate all of your social networks in there. It'll put the data in there. Remember, I talked about import. It'll put the data in there for you. And then after that, it will allow you to kind of go in and query that information as well. Right? And so it will kind of walk you through step by step of how exactly you would go through this implementation. So I won't do this now because that will overwrite what I already have. But if you when you do get the chance, what I would say is please do go in and try and run a couple of these workbooks. So if you can get it on the sample data sets, what it does is it actually gives you step by step what you need to run in terms of the query, the database, and it shows you how the results are coming out as well. So it just gets you very familiar with running these different types of queries and things like that, right? And obviously, if that's something that interests you, and then actually expanding out that knowledge further into how you actually implement it, that becomes even more interesting to look at, right? Great. So what I'll do is I'll leave that with you. I mean, that's probably a whole 12-week course on that. But you can these little sample data sets make it easy for you to kind of go in and explore it. So the next thing I'm going to do is, so now we have set up instance. Let's go back to instance. Let's close these out. Right, and I'm just going to explore this here. So now essentially what I have is in the cloud, I have a graph database running, and I can actually now talk to this graph database, right? So now what I'm going to do is we'll leave that aside for the moment. We'll come back to that. The next thing I'm going to talk about is GitHub. Uh, have all of you used GitHub, or all of you have an account of some sort on GitHub?
Yeah.
Oh, that's great. Okay. So if you don't, I mean, that's something always that you can create, right? So I'm just going to put a repository into the chat. Basically, what I've done is I've uploaded a set of notebooks, right? I'm assuming all of you have used Google Colab. I saw that there were some activities
Yeah,
that
yeah,
you've done. Okay,
that's a
great.
good assumption.
Okay, great. So in that case, I'm just put a couple of notebooks here. What you can do is you can download these notebooks, open them up in Colab, and run them, right? I'll show you how to do that. Regarding GitHub, I think GitHub is a very good place for you to kind of it's almost like a LinkedIn, right? Like all of the different implementations that you do, let's say even if you're doing a classwork, a personal project, or something that you really want to showcase, the code that you have, it's always the good thing to kind of have a repository for it, right? And GitHub becomes this really good place where you can actually go and push all of this information, all of these different types of things that you're working on. And why is that important? If you look at GitHub in itself, it is like the repository for all different types of um, projects, right? And I'll just show you this. Right. So under my account, you have different types of projects, but actually you can actually go into, you can browse some of the more common ones. So if you go to repositories, these are all mine. Let me see if I can find. So let's say if I was going to look at something like Neo4j, right? So Neo4j was the graph database. I want to look at their GitHub, right? So if you go in here in Neo4j's GitHub, they have all of the different types of resources that are pertaining to them, right? Similarly, and each of these resources will have, these repositories will have different content which pertains to some project they've been working on. And you can imagine, and similarly, there are also people who actually use GitHub. So this is just an organization, but there are developers and different types of data scientists who actually use GitHub as well. Not only data scientists, there are many people who actually use. And what they do is they take all the information, or they take all of the projects that they have and the things that they're working on, artifacts that they're working on, and they showcase it here. So now let's say if you want to show someone all the things that you've been working on in terms of a workable code, you can just say, hey, you can go and check my GitHub profile out, and you will see all my code available there. You can actually download it, use it, or distribute it the way you want. And it becomes a really good showcase, and it becomes a good place where you can actually interact with each other. For instance, if you take Neo4j here, I can actually go in and I can contribute to this, right? I can go in, I can fork this code, and then I can go and change different things on this code that they have. And then I can send it back to them saying, hey, this thing, I think you can change this way. Do you want to merge it back to repository? So it becomes this really good collaboration portal as well, right? And so I won't go too much into the internals of it, but GitHub, I think is an always good thing to have on your portfolio uh, if that's something you can actually look into. Right. So for this purpose, for what we're going to do now, I have put all of the notebooks we're going to run into GitHub. I put the link in the chat there, which already has all the notebooks that we're going to run. And as you can see, when you open up your GitHub repository, it just opens up like this, and you can see all of this. Now, this particular repository that I have here, I've made it public, and that's why you can all see it. You can also have private repositories where you have to invite different people separately, right? So that's another way that you can actually, keep only collaborate with a very few people on a certain implementation. Great. And it's possible that over the course of your course, you might actually encounter GitHub in different ways or forms. But I'll leave that to you to actually explore on your own. But that's something that, you can actually look at. So the first thing we'll do is, now I want to take one of these, this one. I'm going to use this workshop intro to transformers, and I want to run this on Colab, right? So one thing I can do is I can just download this raw file, right? So if I say download, it'll kind of download it here. And then what I can do is I can actually take it here and I can upload it into Google Drive, right? So I'm just going to drag this over here. I'll keep both files, right? And then once download, I can double click on this and it'll open it up for me in Google Colab, right? And generally the reason that's happening is Colab in itself is a notebook format, right? So when you look at an Iron Python file and you open it up in Colab, it recognizes that it's a notebook format and is able to run it the way you want, right? So the other way you can do this is, let's say if it's a GitHub repository, what you can do is you can actually copy this URL, right? So this part of the URL, this is what tells, this is obviously the unique location for that particular notebook. I can copy this. I can come here to Google Colab. And what I have to do is, so this is the core URL for Google Colab, right? Colab.research.google.com. I can do slash here. I will put GitHub. I put a separate, another slash there and paste that URL, right? So if you look at this, the only thing I'm taking away from here is, let's do this. The only thing I'm taking away from there is this HTTPS section, right? And this .com section. And if I just enter there, it'll open that up directly into Colab as well, right? So two ways you can open it, open the file and use it, right? So now you're in Colab, right? So now what we're going to do is, this is just kind of setting the background. So we had a look at Neo4j, had a look at GitHub, and now we are in Colab. What we'll do is we'll think back to yesterday. We remember we were talking about Hugging Face and how we can use libraries within Hugging Face. So here I've just done a notebook here just to give you an idea of the different things that you can do with some of the models from Hugging Face, right? So in here, we have this notebook here. I've actually annotated it with different types of with what it can do and what can be done here. So this is just an introduction to transformers with Hugging Face. And what you're going to do is you're going to learn some basics of using these pre-trained transformer models for doing things like text classification or summarization and the like. And this is what we spoke about yesterday, right? Like, there's this branch of natural language processing, and there's different type of use cases that you can actually use to be able to implement things, right? So then you open up Introduction to Transformers. The first thing that you can do is you would install some of these dependencies. So these transformers and datasets are two libraries that are provided by Hugging Face themselves, right? And so they're available on Python or the PyPy repository. Essentially, you can use pip and you can install these dependencies into Colab, right? So if you see here in Colab, if you use this exclamation mark, what it does is it actually goes and runs something on the command line in your machine. So if you look at this, right, I'm just connecting it up now. But this Colab, when actually Colab opens up at the back end of the Colab, there is a little machine that's running, right? Like a little computer, right? And so let's say if you want to run commands on your computer, generally you'll open up the terminal, right? So this is essentially telling the implementation that you want to open up the terminal and run this command there to be able to install these libraries, right? So, I mean, obviously, if I can run it, then it'll go ahead and install these two libraries. So the reason I want these two libraries, one of the libraries actually gives me, remember we talked about datasets yesterday when we were looking at Hugging Face, there were datasets and there were models, right? The datasets library actually gives me access to the datasets that are there, right? I don't need to kind of download them and bring them here. Using the datasets library, I can pull the data through. The transformers library, what it does is it gives me access to the models, right? So I have the datasets on one hand, and on the other hand, I have the models now, just using these two libraries, right? So the first thing that we can do is maybe let's look at how we can do a sentiment analysis, right? If you remember, we were actually looking at how we can do certain types. Maybe what I'll do is I'll open that up as well. So let's say if you were to go to Hugging Face, I don't want to look at the spaces. I want to look at the models. Maybe I can come here, look at text classification. Can I find those here? Tasks. And let's see if we were to search for sentiment. Right here. Text generation. See if I can find classification. So I can look at text classification, right? And then it actually shows me all the different ways that I can use text classification. So let's see if I look at this one here. If I want to use this, I have to use this code here, right? I have to import the transformers library, import a pipeline, and then I can tell it what type of task I want to do there, right? So similarly, here, what I'm going to do is I want to do some sentiment analysis, right? And so for that, what I'm doing is I'm going to use this classifier. So first I'm going to import the transformers library and take the pipeline there. And then I'm going to create a classifier for myself, which can do sentiment analysis, right? And so if I run this, basically what will happen is now it's going to do sentiment analysis and it's going to use the default model that is there, that is set up here. Right, so it's now just going in and running that code. If I want to actually create a specific model, then what I can do is I can actually use this text here, and then I can actually use the specific model for this particular implementation. Right, so let me just see if I can find that here. You can see here the model name. If I use this name, then it will use this specific model from Hugging Face. And similarly, if I go to any of the other kind of models, I can use any of these as well if I want, right? All within Hugging Face itself. So let me just go back here. So you can see what's happened first is it has actually downloaded the model. So because I did not put a model here in this, I had not specified a model, it's actually looking at the Distilbert base model, which is a fine-tuning model. And now it's downloading it first, and then it's running the sentiment analysis on top of it. And so this is a basic sentiment analysis, right? So it looked at I looked at the text, and based on that, it's giving me a 99% positive score in terms of sentiment analysis. So that's just using it for text analysis for something like classification, which is sentiment analysis. Here, of course, I'm just trying to do something on summarizing. So let's say if I want to do summarizing, all I have to do is now I have to just switch the task within the pipeline. And what that does is that will just go in. It will download a different model now because obviously I want to do summarization instead. So it's going in and it's downloading the default model for summarization. Let's see which one is there. And see, you can see that it's saying using a pipeline without specifying a model name is not recommended. It's generally good to have a model in place there. But here, since we're just trying it out, I thought it's okay to kind of use it the way it is. So you can see it's now downloading the model. Right, so it's taken this text now, right, and it has summarized it to a very small piece of information, right? And so I can give what I want to do in terms of the summarization here. I've just given, I want it maximum length of 25, minimum length of 5, and this is how it kind of works in terms of summarization. So all of this information is available on Hugging Face on how to use these models as well. Similarly, now we come to something that we have been working. This is for question answering, right? So this is where you can give a context and then based on that context, ask a question, right? So here again, it uses a different model to be able to do this. And all of this you can see on Hugging Face under those tasks. All of these different type of tasks are modeled. And also it shows you what kind of models you can use them and how popular they are. So you can check them through. So let's say question answering, if you were to filter by so table question and answering. See, these are all table-based question and answering platforms, right? And similarly, you have things like text classification, question answering without. So that's for tabular data. This is for standard question answering. This is for zero set classification. And so all of these different things, we can actually go in and use it, right? So basically here now we had given a context for Hugging Face, and then we had asked, what does Hugging Face provide? It went in and pulled that information out from there, just using that model. So these are very simple use cases. But the power of this is now you can actually run this across multiple data sets, right? So they are using this for one, but if you were to be able to loop through the information you have, let's say if you have a CSV full of items, let's say a movie database that you want to go through and you want to classify all the sentiments for each of the reviews that are there, you can just run this pipeline and just iterate over it using a model of your choice, right? And then you can actually compare to see which models are better. And then this becomes very powerful in terms of even using it within production grade work, right? Your practical use cases, right? So similarly, I've given various different types of use cases here, right? And you can run them and you can make sure that you kind of you can try this out within Colab itself. One thing I will also do is I will also provide a couple of other notebooks which actually give you more kind of use cases, right? So there's one notebook I had which actually downloads the movies database and it's able to kind of do a sentiment analysis. I'll see if I have that here. If there's there, I'll quickly show you what that is about as well. So now I'm switching to the, yeah, so that is, sorry, that is the, I have it in a different place. I'll upload that here as well. And that is something you can try out. So this is just to kind of give you a background on what Hugging Face and how it works, right? Then what we can do is, next is I will, remember we talked about prompt engineering. So this is just a bit of a workshop or like a workbook, which will be able to get you started on prompt engineering. So one of the things that you would see generally is you use prompt engineering through an interface of some sort, right? So essentially you would go to a ChatGPT or you might go to a Claude or you might go to a Gemini. In this case, what we're trying to do is we want to run these from the code. We want to use code to be able to call these models absent of their platforms, right? And so this becomes powerful because now we can integrate these within our applications as well. Like Walter said initially, he was talking about how we have applications and within them, we have user interfaces and then we have object-oriented programming we can use to actually build out these applications. So what you can do is you can actually integrate your large language model calls within the application itself, right? So it might be that, let's say when a person comes in the morning, you can analyze maybe their calendar, and you can send that through to a text summarization kind of model, and then give them some suggestions on how to kind of what are the main things that they have for the day for them, right? So all of these things you can do with code. So what I'm going to show you here is basically how you can start off with your prompt engineering. So what I'm going to do is, remember how we used the URL. So I'm going to take that URL from there, push it in here. And I'm just going to leave and go to the next thing. So here now, this is essentially all around prompt engineering, right? And different types of prompting that you can do. So there are two here that I've actually given out. One is basically chain of thought prompting, and the other one is basically few shot prompting. I think what's happened here is this is the wrong notebook. I will get this over to you. I will get this over to you in the library as well. I think this is the wrong one that's come in. It has not got completely implemented yet. Right. So one extra thing I want to mention is, let's say if you don't want to be copying all of these different things over, you can also open up your notebooks in this way. You can actually say upload, and then you can, whatever you download, you can browse from here and upload it as well, right? So there are multiple ways to actually get in there. So if you get stuck in one way, don't worry, there are other ways to do it. Great. And so with that, what we'll do is we'll go into one of the main things that we were going to look at. You remember how we talked about embeddings and transformers and similarity search? So this notebook actually looks at this in a bit of detail, right? So as usual, I will copy over this URL, come here and open it up in Colab. Sorry. There's always a sinking feeling when that happens. Right. No, got that wrong. Right. right? So essentially what's going to happen here is we're going to look at this thing of embeddings, transformers, and similarity search. And for this example, we're going to use essentially a university type domain. We're going to have two people, Alice and Bob, who are student professor relatively, and they're going to be part of a research group or energy users group. And then we're going to ask some questions around these different these relationships, right? And if you looked at your knowledge graph that we had put in Neo4j, this is the kind of structure that we had created there as well, right? So we'll get to that. So the first thing we will do is, I mean, again, there's a lot of textual description here just to get you started. So these are some of the things that we are going to try and do, right? So the first thing we'll do is we're going to use Hugging Face, right? So for that, we're going to install this set of libraries here. What I'll do is maybe I'll just run these so that they get started. Right. It takes a little bit of a while to install this because we are using PyTorch here. PyTorch is basically a machine learning platform. The reason I used PyTorch here is because I just wanted to show you some of the nuances behind some of what we were talking about earlier, right? In terms of how we are doing these embeddings and how they're actually implemented out. So basically now let this install in the background. And then I'll talk a little bit about what we're going to be doing here. So first thing we're going to do is, remember how we talked about how we get word embeddings or sentence embeddings? What we do is we use an embedding model, right? So here what I'm going to do is I'm going to use this model called All Mini LM L6V2. This is one of the models from Hugging Face, right? So we're going to use this model to be able to embed, basically embed the words that we have. And then we're going to use that to be able to do some similarity search afterwards, right? So we get this sentence from transformer from a pre-trained model. And then, so let's see if it is running. So this will take a while to run. As you can see, it's quite a large library of items to run. So I'll just let it run because I've already run it again. So I can show you what the results of this are going to be like, right? So then what we do is we actually look at the libraries we need to run the transformer models in Colab, and we use a small encoder model. And then we are loading it up into a tokenizer. Do you remember what a tokenizer is, or what a token was from yesterday's conversation? Does anyone remember?
No, you can please repeat that.
Yeah, do you remember what a token is, or what a token was when we were talking about sentence embeddings and word embeddings and the like? Do you remember what a token was in that context?
Is it the representation of
No,
it?
it was basically remember how a sentence has many words, and it has many different or many words and many parts of speech. A tokenization essentially broke up a big word into these tokens that can be then represented within the space, right? So tokenizer is essentially splitting up, for lack of a better word, right? So the tokenizer essentially takes your sentence or your paragraph or whatever it might be and splits it up into manageable chunks of data, right? And then from there, what we're going to do is we're going to load a model to be able to do our implementation, or basically our embedding, right? So the first thing we're going to do is we're going to actually load up a little bit of a corpus of data, right? So remember we talked about how retrieval augmented generation works. Basically, we have a corpus of data, right? So it might be documents, or it might be some sort of knowledge that is represented in terms of in a database. So here what we're going to do is we're like defining a small text database, right? So these are corpus. And in this, what we have is we have some keys, right? And also we have some information against those keys. So it's a very small text database, right? And so essentially we are defining that here. Then what we're going to do is we're going to take this corpus here, right? And then we're going to take each row, or we're going to take a row here, and we are going to tokenize it, right? So the first one we're going to use is we're going to use this corpus row, which is Alice profile. Alice is a PhD student researching neurosymbolic AI, knowledge graphs and reasoning systems. And if you run it through these set of code or through this tokenizer, this is what happens, right? So this is the standard text. In the tokens, what happens is it gets broken up like this. So you can see these are now the tokens that are going to be used within the embedding scheme, right? So basically, we need to embed each of these tokens into a vector representation in order to be able to do some computation on it, right? So that's the first step that happens. So we are just looking at the first 40. And once the tokens are created, when you're representing it, it actually has an ID against each of these tokens, right? And so these are essentially the IDs for those tokens. So now what has happened is, okay, you have taken some text and you have made it machine compatible, right, to do some calculation. Right. So the next thing you're going to be doing is we are actually going to be looking at some of the subword tokenizations that happens, right? So basically, we're going to see, like, even if you take a token, generally it's not always a single word. Sometimes even parts of a word get split up when you are doing tokenization, right? So that's what this is showing here. So we have three different words. Alice works on neurosymbolic reasoning. We have neurosymbolic with a hyphen, and we have neurosymbolic with a capital S here, right? And so if you look at the different ways that this tokenizes, you can see here, in the first instance, it actually takes ni and euro as two separate tokens, right? Then if you take the hyphen, it takes it as three separate tokens, right? And when we look at neurosymbolic reasoning, it actually takes it as, again, 3 or 4 different tokens, because that is the way the tokenizer is actually going in and breaking up those text chunks, right? I mean, so the why that is, it's not very important. I mean, if that's something that you want to look into, just drop me an email. I can explain that a little bit more in detail. But here, essentially what's happening is this tokenizer, for every different type of these representations, it will create different sets of tokens, right? But semantically, they all are the same, right? And so that's the interesting thing. All of this, when it's represented in the vector space, there is similarities will be very close to each other because they're semantically the same, right? So then we come to this whole concept of attention, right? So attention, like we talked about yesterday, is like one of the fundamental building blocks in the transformer. Essentially, what attention does is, and I've just given a bit of narrative here of how this works. So attention, what it does is, it actually allows you to take a sentence, split it into the different tokens, and then weight each of the tokens in terms of their importance within the sentence, right? So you can see here, things like on are not very important, but things like Alice and reasoning and neurosymbolic, all of those are more important in terms of the context that they're bringing or the meaning that they're bringing, right? So what this attention does is it actually goes in and it creates, it gives a relative meaning or gives context to each of the words in terms of all the other words that are there. Right, and this is what actually powers this thing of retrieval augmented generation. So I given a bit of a reading here. You can just read through this, and that will hopefully it'll give you a bit more context to this as well. Right. Right. So now we come to this point of where we're going to turn this into actual vectors, right? So all this time, but we're still working in a text space. Essentially, we have taken this text, we have broken it up into tokens, and now it is available for us to actually turn into vectors now. And that is where this is where embeddings actually come into play. Right. So what this is going to do is it's going to actually use a transformer. So we are defining two functions. One is this embed sentence, and the other one, this is what you call mean pool. So what is happening here is, if you remember, when we do embeddings, we are taking word by word and embedding them, right? Because each word becomes a single embedding. But what if we want to actually bring them all together and give context to a sentence? That is what we're doing here. We are actually taking each of the words, we are tokenizing them, and then we are kind of combining them together in this form to be able to get a combined representation of all of these words in context of a sentence, right? And so that's essentially what this code is doing, right? I'll talk just very briefly about this concept of a mask. So normally when you kind of do any sort of machine learning representation or machine learning, your vectors need to be of the same size, right? And if you take a lot of these words and tokens, they are not of the same size. So masking, what it does is it essentially goes in and pads the all the vectors so they are of the same size, right? And so at the end of this code, what happens is we're taking each of the words in that sentence, we are kind of giving them a vector representation, and then we are going in and combining those vectors together to get a single resultant vector, which now represents the sentence in itself. Right? And that is exactly what's happening here. Right now, so once that is done, now what we can do is we have taken this sentence and now we have embedded it, right? So once we have done this embedding, now what we can do is we can ask questions. And then what we can do is we can see which of these different corpus texts. So for instance, which of these texts, which of these texts are most similar to our question? And then we can bring that into context to be able to use in retrieval augmented generation, right? So I'll just show you how that happens. This is what you call a similarity search, and we're doing this in memory. Normally, what we do is we do it in a vector database, similar to Neo4j. You might have something like VV8, or you might have something like Phage, or you might have something like ChromaDB. We're not using that. We're just doing it in memory. So what we're doing here is, so we will actually take these words, we will vectorize them, and then do cosine similarity. Right, so I believe all of you would know what cosine similarity is. Essentially, that is the way to look at.
They worked with this concept in the last lab. Yes.
Lovely. Okay. Great. Thanks, Evgeny. So now you'll be very familiar with that. What we're trying to do is we're trying to see, how similar the question is to the set of corpus that we have. Right. So here what we're doing is we are embedding the sentence. So this is the query. We are running it through the embed sentence the embedding function here, which is then calling on to the mean. Basically, that's taking the sentence words and kind of pulling them together to create a single representation. And then what it's doing is it's actually going to score each of these versus the corpus we have, right? So remember the corpus is basically all these different, these set of text that's available, or rows or documents, as it were, and going to see which ones are most similar, right? And then it gives a score based on how similar they are, right? And so basically what we're trying to ask is who works on neurosymbolic reasoning, right? So and based on this, it actually picks up Alice because it is semantically similar, and saying this is probably the most similar in terms of the information that you have to that question, right? So that's how you're kind of actually taking a semantic or semantic closeness between these vectors or between these sentences and words, right? So one of the interesting things here, though, is embeddings or retrieve similar text, right, or semantically similar text, but they don't guarantee the logical entailment, or basically they don't logically guarantee that they are, related in some way or form, right? And that is where something like a graph database becomes important, right? And so if you were to look, if you were to look at this example, so now we are using a different query, which is who supervises Alice, right? What it does is, again, we do the same thing. We actually take this, we embed it, and then we run it a cosine similarity against all of our four different documents that are there. And this is the scoring that's available, right? So, but what you can see here is what would be most pertinent for who supervises Alice would be this, right? Bob. But what's happening is the most semantically similar one is the first one, right? So you can see that like now it is not as intuitive, or it is not intuitive to be able to answer this question because it's getting the most similar one, but it's not really getting the information that we really need to be able to answer this question, right? And so that is where this graph database or Neo4j actually comes into being. Okay, great. Any questions on that? So I think we kind of went through quite a lot of different things there. And that's why I've given you the notebooks. You can run them at your leisure and just kind of look through this. And you can always come back with questions if you have any. Did you have any questions on this? If not, I'll go to the next one. All right, great. Hopefully it was not clear as mud. It is rather more clear than that. Okay, the second one I'm going to look at is, right, so we did embeddings, right? We did embeddings, and now what we know is we can actually compute the similarity between the corpus and the words, or basically some of the phrases that we have. So now let's get into how do we actually use this within a retrieval augmented generation function, right? So this notebook actually talks about retrieval augmented generation with a single agent, right? So here what we're going to do is we're going to use a few things. We're going to use LangChain. LangChain is essentially an LLM or a large language model framework. To make it very simple, it's a framework that's able to leverage large language models for various tasks, right? So LangChain is one of the any important one which came out very recently. And recently they made the first version of it, but it's quite a powerful framework to use. Similar to LangChain, you have other things such as you also have Llama Index. That's another one that's popularly used. You have each of the labs that have their own set of kind of libraries. You have Strands, which is part of AWS. And so you have a lot of different libraries, but LangChain is generally a safe bet to go with because there's a lot of resources and there are a lot of people actually commentating on it quite often, right? So, I mean, that's one thing about choosing libraries, especially on GitHub or when you're kind of doing this work. Always choose libraries that have a lot of maintainers behind it, right? Because a lot of them are open source. And because of that, there can be bugs, there can be issues, there can be very intricate ways that you have to use it. And having as much commentary and a community behind it makes it easy to kind of follow, right? So this is a single agent with reg, right? So what we have to do is we have to set up one thing, which you have to set up an OpenAI key, right? So for that, what I'll do is I will copy in a key here so that you can use it when you're running. Just be mindful of how you use it. I mean, it's got a budget on it, but I mean, keys are generally quite dangerous to share out there. Right, so that is your OpenAI key. You can use that. Basically, what it does is it gives you access to a large language model and being able to run it, right? So when you run this, essentially it'll open up a text box. I'll show you what that does. Bring it up. So what it will is give you a text box here. What you'll do is just copy this OpenAI key, which is in the Zoom chat. You'll push it in here. So it's already there. So I will copy it in. And just press enter and it gets added in, right? Then what we do is we actually define a corpus. Again, similar to what we did last time around, we're going to define a corpus of work so that we are calling it, we are using a document object. So we are using LangChain's core here. If you remember last time, what we did was we just created a list, right? So what LangChain does it gives you a couple of wrapper functions. You can define documents as documents. You know, it has kind of helper functions which you can use to then use it, right? So we are adding some content and also we are adding some metadata to that content, right? So we are talking about entity as Alice, type as person, and some information about that entity, right? And all of that we're putting in. So one additional thing that we're adding here is a university policy about how people should be using their tools as well, right? So all of this is now going into my little document database. So, I mean, this is just a toy data set. So I'm just showing you 4 things, but in reality, practical organizational world, you would have millions of these, right? Millions of documents with text in them. And there would be multiple reams of text. And it won't be only that, you might have images, you would have audio, you would have Excel spreadsheets, you would have data sets. So all of those become this data repository. For the moment, I'm just showing you in terms of a text modality, a little toy data set. Right. So the next thing I'm going to do is build a vector store. Remember, we talked about when we're doing vector based information, we will do it in a vector database. So here we're actually building a vector store. We're building a vector database in memory, right? So we are using this thing called Face, right? So Face is essentially it's a vector database that's developed by Facebook. And it's quite powerful in the way that it works, right? So here what you can do essentially it's like a storage space or like a database for vectors, right? Or word embeddings, right? So for lack of a better thing, basically you're just taking word embeddings and storing them in your vector database, right? Also, what we're going to do is, instead of, remember last time to do the embeddings, we used the Hugging Face model. This time we're going to use the OpenAI model, right? OpenAI also has their own embeddings implementations that we can actually use within here. So we're going to use one of those. So this is what you call text embeddings 3 small, right? So just to give you some context, what I'll do is I'll show you that. So if you look at embedding models, right? So these are all the vector embedding models from OpenAI, right? So you can see there are different types of models you can use. So we are using this one here, right? It's a small model. So basically, it's what it does is it actually it runs much faster, but it's not as effective as some of these larger models in terms of the embeddings. And what does that mean? Essentially, it captures less detail than what the larger embedding model would. So we're going to use this within our notebook, right? Yes, right. So we are using that here. And essentially what we're doing first is we are chunking the documents. So here we are splitting it up. Remember how we talked about when we do RAG, we split up the documents. So here we are doing the splitting. And these are the functions that we're using for that, right? Then what we're doing is we're using these chunks of data. So basically we're taking a document, we are splitting it up into multiple pieces, and then we are creating a vector index, right? So basically we're putting it into a vector store, right? So that's why we're calling face, and then we are adding these chunks in. And also what we're doing is we're sending the embedding in as well, right? Embedding model in. So what will happen is, in this, it'll take the document, it'll split it up into pieces, then it'll take each of those pieces and it'll embed them as a word embedding using this model, right? And so the reason we are able to just use it very simply here rather than like we did the first time is there are already libraries that are available for this, right? So the first notebook that we had, it kind of broke it down in terms of what it's doing. Once that is done, we create something called a retriever, right? So what this does is it's able to kind of retrieve all of the chunks from the database. So this is we were just checking for how many chunks there are, and there are 4 sets of documents there, right? Which we're pulling there, because obviously the documents were quite small. It didn't need to be chunked into multiple pieces, right? But if you were, let's say, if you were to take the works of Shakespeare, that would be many different chunks that need to go in there to be able to represent all of those. Right. And so now what we can do is we can actually do a retrieval, right? So we can actually remember how we did the semantic similarity. We are using a question, say, who works on symbolic neurosymbolic reasoning, and we are asking it to give us the top 3 hits, right? So what it does is it orders it and it gives us the top 3 hits, and this makes sense, right? So this is the most similar one, but these also have some sort of similarity in terms of the database. So it's just giving us the top 3. If you were to ask for one, what it will do is it will just give us the top one, right? And that is generally what RAG is. You're trying to get the most closest document evidence information pieces to be able to use with your query, right? Then what we're going to do is, okay, so now we know how to retrieve things, right? So basically using LangChain, now we can actually give a query, and using this query, now we can retrieve the most similar kind of documents that will help us in our implementation, right? So what we're going to do now is we're going to wrap this as a tool. Remember, we talked about agents last week, and in agents, sorry, not last week, yesterday, we talked about how agents have tools that they can use for certain things. So this capability of being able to get the most relevant documents, what we're going to do is we're going to wrap it into a tool call, right? So this is a RAG retriever. So essentially, it's retrieving the most similar documents from our database. So we are going to wrap this using a tool, right? So we use this functionality, and now what we can do is we can actually create a tool, right? So what we'll do is we'll create this tool and we'll give it to the agent that we're going to develop, right? So generally, you can have multiple tools as we have talked about, but since we are doing only one tool here, I'm going to pass it to my tool stack, and I'm just going to implement it there. So basically now this will create this tool using this code, right? So essentially it's using the same functionality. It's just wrapping it up as a tool that can be used by an agent, and it's providing it as a toolbox, right? Now what I'm going to do is I'm going to create an agent, right? And so how do we create an agent? This is how we would do that. First, we will define the model that's going to be used within the agent. So generally agents, they use a model, right? So as we talked about the agents, when you talk about the agent, it's basically a large language model that actually powers that agent, right? So here we are actually defining that model. Again, these are using libraries. So essentially I can just say what type of model I'm going to use. I'm going to use GPT-4o mini. Again, to give you some context, if I was to go to OpenAI models, right, I can probably look at the compare models. These are all the different types of models that you have available, right? So of all of these models, we are trying to use, we're trying to use GPT-4o mini, right? So using some of these smaller models means your costs are much less, right? If you use GPT-4o, it's a lot more expensive, right? So we are wrapping that up. We are also taking the tool. Remember the tool that we created? We're going to take that tool. We're going to take our model, and then we are going to create our agent. So remember, we can create an agent. How do we create it? We create it with a tool, and then we have like your capabilities, which is your model. If you remember, we had some other things also. We had memory, we had planning. We are not going to give any of those complexities here. We are just giving it the ability to use only tools for the moment, right? But obviously, when your agents become more capable, you can actually go in and add in all of those as well, like short-term memory, long-term memory, and all of those different things. Right. So then what we're going to do is we are going to actually tell our agent, we're going to ask this question. The same question that we asked here, instead what we're going to do now is we're going to ask it in terms of the tool. Right. And so this is what it does, right? So if you look at it, this is the actual raw message that are coming up. So because this is an API, right? In the API, this is the raw message that comes up. These are all JSON based. Essentially, this is the human message that's going out about these messages. So who works on neurosymbolic reasoning? Can you use the tool to make the answer? Right? So then what happens is the response is coming in, and this is the AI message, right? So we are not really putting a system prompt in there. And when the response comes, it tells us how many tokens we have used, how many tokens were passed in terms of the prompt. It gives us all of that information. This is all the kind of tokens that are used to kind of cost out how much the API costs us. And then it tells us about which model provider is being used and which model is being tagged to. It gives some information here. It says what tool calls it's going to be using, right? And here, this is basically the tool call. The actual tool call is saying use my university retriever. So that is the tool that we had defined. The query is neurosymbolic reasoning. That is what we had asked, right? And then it's actually sending that information into the large language model, right? So your question might be, okay, how is this different? Like, how does this really, how is this different from just pushing everything into the language itself or into the prompt itself? The difference here is what happens is the tool gets called separately, and then the answer for the tool is used in the context, right? Which is powerful because if you think of things like calculations, the large language models are generally, now they are quite good, but those in the days gone by, they were not very good at them, right? So there are many things that the large language models are not good at. So using tools, you can actually use deterministic code, which can do the work and then provide the answer to the model, which then goes out and kind of gives you the answer back. Right. And it's almost like having an intern, right? So let's say you're not really good at a certain type of thing. Maybe you have employees for you. When you get a query, you kind of pass it off to that employee to give you the answer to that query. You take that answer, you reason with it, and you give the answer back to whoever asked you that question. Right? Very simple, similar kind of implementation. So if you were to run this, what it does is it goes back, and this is the answer that it brings back. Let me see if I can find the answer. So if you were to look at this, this is the AI message. And so this is the answer that comes back, right? Who works on neurosymbolic reasoning? So this is the answer. Alice is the student who is working on it, and her work contributes to understanding development of neurosymbolic architectures, right? So this is the information that's actually going in, and that's the answer that's coming out from this agent invoke, right? And so this, remember, we had a policy question. This basically is invoking the policy question, and that answer is also coming back using that tool. So essentially, the tool is doing the similarity search. It's picking the most relevant document and it's passing it in here. And then using that, the large language model is now answering us, right? So if you remember, we used k equal 3 here. What that meant is you'll get the top 3. If you remember, we had 3 here, we changed it to 1. And that is why it's getting the top 3 information pieces which are most similar, right? So it's basically taking those 3 things and it's pushing it through the large language model, right? So I'll quickly work through the next one as well, right? So essentially what's happening here is, remember we used only, in our last example, we used the RAG agent, and we used only retrieval augmented generation with a vector database. So what we're going to do here is, you're going to use the single agent with a RAG database and also with a knowledge graph as well, right? So these are basically where you just set up the OpenAI key and also the URI. So these information you will get from your here if you come to your instances. When you create your instance the first time around, you would be getting a set of keys that you can use, right? And so those are the keys that you have to kind of retain for yourself. And you would have been asked to retain it. You can take that key and then you can use, see if I can find it here. If it doesn't, you can just delete the instance and recreate it. What you can do is you can take the keys from there, and those are the keys that you will use here as well, right? So once you've set that up, now what we're going to do is, first we're going to see the tiny university-based knowledge graph, right? So this is how we are actually creating that here. We are using this keyword called merge. We are creating a class of person. We are creating a class of student. We're getting a class of a PhD student, an academic, a professor, and then we are doing the linking, right? So we are saying a professor is of a class professor. We're linking a student to a person, a PhD to a student, an academic to a person, the professors to academic. So now you can see that we're creating this knowledge graph of how this student and this professor, or the student and this academic, actually live within this knowledge world, right? And then we are kind of making those relationships using this. And once that happens, now you have your knowledge graph, right? So this is just seeding it. And these are the relationships that are made. There are 4 types of nodes, 3 types of nodes. And then you have people who are getting assigned within those nodes, and then you're getting the relationships built within them. So this part we did already in the second notebook, where we built a retrieval augmented generation, or kind of a vector-based search index or a database. Now what we're going to do is we're going to actually build a knowledge graph-based tool as well, right? So now what do we have here? In this setup, we have a knowledge graph, which actually has the truth about how a university is set up in terms of these 2 people. We have a vector database, which has the same information in terms of in terms of documents based on this information. So textual information. So the relationships are in the knowledge graph. All of the semantic meanings are in the vector database, right? And if you remember, you can actually combine the two. In Neo4j, you can actually have this vector database also within the knowledge graph, but we won't mix the two at the moment. But that is also possible, right? But at the moment, we have a knowledge graph, we have a vector database, and now we're going to use both of these tools, or we're going to use both of this information to be able to create, to be able to do questions, right? So what we do is we build out a knowledge graph tool. Very similarly, we actually build it out here, right? So we are using this prompt to actually within the knowledge graph tool. So what does this knowledge graph tool do? Basically, it takes your natural language question and it converts it into a cipher query, right? And then it runs it against the cipher, it runs it against the database and brings the data back, right? So that's what we're doing in terms of setting this up, right? And then what we're going to do is we're going to create an agent and we're going to give it these 2 tools, right? So the first is basically Neo4j, basically a graph retriever tool. And then I'm going to do a vector database tool. So those are the 2 tools. Now I'm going to add them into this tools toolkit and give it to the agent, right? And so when we run the question, basically what happens is, I'll just do it with the tracing on. If you look at the tool trace, basically when you ask anything about relationships, it actually picks this Neo4j tool. It uses the knowledge graph tool. It doesn't use the other tool, right? And if you were to ask anything around actual semantic meaning, it goes and uses the vector database tool, right? So now what you have actually set up is you have created an agent which can actually choose between two different types of tools in being able to answer their questions, right? Great. The final piece, and I won't spend a lot of time on this. I'll just quickly kind of walk through this. Now, we had done a single agent. Now we are going to do this for multiple agents, right? So again, everything is set up the very same way. So we have the knowledge graph and we have the semantic tool. And now those are the two tools. We set up those two tools. Now what we're going to do is we're going to set up different types of agents, right? And how are we actually saying what type of agent there? We have a plan agent who is going to break a goal into sub goals. Remember, I talked about multi-agent systems. You normally try to break it up into sub goals. And then it's going to kind of create different goals, which you can assign to kind of a handoff to other agents to do the work. We are going to have a RAG agent, which runs against the vector database. We are going to have a knowledge graph agent who is able to work against the knowledge graph. And then we are going to have an editor agent who can bring this information together and create a text, right? So how do you do that? You can see here that the way that we define these roles are by using prompts, right? Remember I told you prompt engineering is still king. This is what happens. Basically, this is how we actually making sure each agent knows what they're supposed to do. Right? Then what we do is we actually write out what our goal is. What do we want? Because basically we want to ask these 4 questions and we want answer. And we also want evidence from which tools these answers came back from, right? So then what we do is the first step is we actually take this whole question that we have or this plan that or basically what we want and we give it to the planner agent, right? So the planner agent then goes out and creates the plan, right? So he creates the plan, he or she, and then transfers it on to the other agents to do the work, right? So then what happens is the RAG agent gets called to actually pull up any semantic information. The knowledge graph agent gets called to pull up any knowledge graph-based relational information. And then both of those are then sent into the validator agent, the editor agent, which then actually does the final report. So what it does is it takes all of these different questions and answers it, and it combines it together in the final report, right? So there are a lot of different things that we actually pulled in there. That's the reason I just gave you the workbooks as well. You can just run them the way that you want. And you can maybe take it through very slowly. And you have the recording for some reference as well. But this just to give you like a practical example of how these knowledge graphs get used. And you know that progression from actually having embeddings and vector embeddings and moving that towards the actual practical implementation, right? So that's something I really want to kind of talk through. And the additional part of this would be, you know, the things that you were doing in terms of your neurosymbolic architecture. I think you're using VTB, right? In terms of your bindings and your logical implementation. You can include that here as well, right? So that becomes just another representation that you use, and you might have another tool for that to be able to pull that information. Great. So without further ado, I'll just give that over to Evgeny.
Yeah, Nishan, first of all, it's great. I mean, great. It's like a, cherry on top of the cake, so to say. And I mean, for the record, I want to maybe clarify a little bit. So what Nishan did in this very fast forward manner is more, you should consider more of an opening to practical. Well, call it neurosymbolic, but I would say practical semantic technologies using LLMs and formal knowledge representation. So again, in a slower passion, so it should take much more hours. But I mean, the idea here was, I mean, we in this course, so we started with basics like propositional logic and the whole idea of agentic behavior. So you tried it in the lab one, and then we moved on into semantic technology. So it's and I mentioned that I mean in the old form, it is kind of dead, so because it wasn't scaled. But the interesting thing now is that, I mean, this proliferation of Gen AI models, it just gives a new life to these old technologies, and that's what Nishan has overviewed in this past two lectures. So in the home assignment, you will try a lightweight version of it, so to say. Of course, I mean, kind of stripped down to the level to the level of discourse. But I mean, I really advise you to watch these last two lectures in a slow passion and or in yeah and try to understand how try to get hands dirty on working with graphs. So Nishan, you would send me the both the presentation and the links, right, that you used today, so that I can post. I will post them on the course website. So again, take it very seriously. So that is maybe most acquired, skills now on the AI job market, or not. I mean, AI related job market, but the applications can be plenty. So I don't know. Do you have any questions, the audience? So we have some people online. Questions, comments, anything, thoughts? It was mind blowing, Nishan.
As
No.
long as it was not mind-numbing, I think we're good.
Yeah. Yes, but listen, I really hope you will use it. And as we don't have a dedicated kind of course just on this topic, but so this is, as I said, opening up. Moreover, I want to say that the topics of working with knowledge representation and reasoning is very active research. Well, in my group here, but also in our LTU Square collaboration. So if you have an interest in doing project work, master thesis, or bachelor thesis, whatever, so please contact me, and so together we formulate an interesting stuff around it. All right, that's it for now. Thank you, Nishan, once again. Please send me the files and the
I
links
will.
in a yeah by email, so I will put them online. All right. As for others, so do last poll for questions on anything. So that was the last online occasion when you see me and well Nishan for this end. Anything you want to ask related to course? Well, you always know how to find me on Discord. So
Yeah.
please contact us and ask questions.
Yeah. And if you want to add me there for Discord, I'm happy to kind of field questions there, or you can email me as well. Happy to kind of
Absolutely.
take any.
Absolutely. All
Yeah.
right. Thank you all.
Uh,
And yeah.
and just one more thing. Thank you very much for kind of turning up over these past 2 days. I know it's not always easy to kind of digest this, especially early morning in the dark. But thank you for sticking it out and really kind of giving me the opportunity to kind of share this with you. I mean, just any feedback is really appreciated, and any kind of clarification, happy to kind of jump on board and give you.
And
I
I
mean, there's a
just
lot more. Yeah.
Yeah, I just
Go
want
ahead.
to reveal again for the record. I mean, in our kind of private discussions or private professional discussions, so I know that Nishan works on this constructing, an agent that helps you in all aspects of professional and private life. So that's kind of an interesting side development. So if you have, questions on how to do that, so I guess he will be interested to discuss as well. Okay, great. So good luck with your home assignment and happy holidays. Merry Christmas and Happy New Year all. Bye bye.
Thanks, everyone. See you. Bye.